So now in this video, we have a PNP bipolar junction transistor. The flat side is to the left, so we got emitter at the top, base in the middle, going to that resistor, and then the collector down at the bottom, going to our active buzzer. You just need to put a voltage across it. I think 3 volts will work. We're going to use 5. I don't know how high you can go with that. But in any case, the transistor right now is off. It's not conducting, at least not enough to get it to start buzzing right there. We are going to use a light dependent resistor to turn it on. We need to get enough light on the light dependent resistor to do so. I have a cap on there right now, and of course the buzz is very annoying, so I'm going to try to keep it as short as possible. This buzzer had the paper on there. It says to remove it after washing. I don't need to keep the paper, but I decided to. Since it's an active buzzer, you just put a steady voltage across it, it buzzes. At least all the ones that I have, there's epoxy on the bottom. If there's no epoxy, then I've been finding that they're passive buzzers. It is polarized. There's a plus right there. So I put a plus on the schematic that I drew. But of course, that goes towards the more positive side of the power supply. Make sure I get this into the right spot when I return it. So we got the other pin to the collector right there of the PNP. So I made this in the last video with the NPN bipolar junction transistor, but the buzzer was up there, light dependent resistor was up there. Otherwise, it worked the same. So whatever you can make with the NPN, you can make with the PNP. I'm using the 2N3906. Just polarities are opposite. You got to keep that in mind. We got a little bit of current going this way when you consider conventional current. That causes a lot more to go that way. When it's dark enough, it's kind of like this doesn't exist, and we do need the light dependent resistor though. Or no, we don't need this to turn it on. If we yank that resistor, it will turn on probably almost no matter how dark it gets. Maybe if it's really, really dark, it won't. That's the way it works. So we definitely need that resistor right there, because you can see that current path. If we don't have that, we need that to make sure it turns off. And although if it gets dark enough, this might be able to do it, but it has to be really dark. I'll pluck that, cover it, and yep, okay, we did get it dark enough, so it is possible, but that's going to be very annoying. So I'm just going to pluck that. We saw the voltage divider, the resistor going to the base of the transistor, and it can turn the buzzer on. So yeah, that's really about it. Again, there are different light dependent resistors. Probably any of them will work just fine, and this kind of looks like it. There's little wavy lines on there. I don't know how close we're going to be able to get, but this is a different model number. It's different coloring. The waviness on there looks different, and so it might have a different resistance at a given light, but just like this one here. If it's extremely dark, you're going to have many millions, probably hundreds of millions of ohms of resistance. And if it's really bright, you're probably going to get really close to almost no resistance, maybe like 30 ohms or something like that. So just be aware of that. I'll wire this back up and call it the end right there. So unfortunately, that doesn't want to go in. Sometimes it's stubborn, and we'll get that one. So it's off because it's dark enough, and we got light, it's bright enough. Yeah, that was the other one. I could see it. So in any case, going to turn the power off because this is a very annoying buzz. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.